Hi, everyone, and welcome to this engineering proposal explainer. During our last major monsoon, urban floodwaters actually disabled 40% of our standard emergency vehicles within just the first 2 hours. That single statistic right there highlights exactly why we're all here today. I'm stepping in today as the team leader for SMK Krubong, and I am absolutely thrilled to present our project to you, our city's disaster planning officials. What we're showcasing is our submission for the design category at MIIEX 2026. We call it the Aquashield Rescue Pod. As we're navigating this era of really unpredictable climate shifts, our focus just has to turn toward innovative, community-centered survival solutions. This proposal is a direct, scalable answer to one of the most terrifying natural disasters our neighborhoods face: severe flooding. I am so glad you're here to review this with me today.
Okay, let's dive right into our roadmap for today. We'll start with the Flood Emergency Challenge, introduce the Aquashield Pod itself, explore its survival features and smart rescue tech, look at the broader community benefits, and finally, discuss the future of disaster response. Section 1. The Flood Emergency Challenge, the reality of isolation. Let's quickly ground ourselves in the immediate reality of why this matters so deeply to our infrastructure.
When we look at traditional disaster response protocols, there's a pretty glaring vulnerability. Current systems are heavily dependent on rescue teams and emergency transportation. But when roads become completely inaccessible and the weather gets too dangerous for an immediate dispatch, the harsh reality is that victims become stranded. They're trapped in rising waters, totally isolated from food, clean water, medical supplies, and shelter. There is a literal life-or-death need for a portable, floating emergency support system. By implementing specific risk mitigation strategies for extreme weather, specifically focusing on immediate on-site survival, our models actually quantify a potential reduction in victim fatality rates by up to 60%. We absolutely must bridge that terrifying gap between initial isolation and official rescue.
Moving right along to Section 2, introducing the Aquashield Pod, Floating Hope. This brings us directly to our engineering solution.
The Aquashield Rescue Pod is engineered first and foremost with a highly resilient floating safety design. It functions as both a temporary emergency shelter and a floating survival support system. Now, to ensure absolute structural stability during those high-velocity currents, the pod is constructed using high-density polyethylene, reinforced with a carbon fiber exoskeleton. This exact combination of materials provides incredible durability against the heavy debris impacts you constantly see in extreme flash floods. Instead of asking victims to climb onto dangerous rooftops, we're providing a secure, purpose-built station. We've built strict safety protocols right into the buoyancy design, utilizing counterweighted ballasts. So no matter what, the pod remains entirely stable and upright on turbulent floodwaters, keeping victims safely elevated above the rising tide.
Section 3. Essential survival features, sustaining life. Remaining above water is crucial, but it's really only the first step. The pod must also actively sustain the lives of the people huddled inside, so it doubles as a comprehensive emergency supplies storage unit. We specifically engineered it with 250 cubic liters of watertight storage that easily handles the capacity requirements for essential medical supplies, trauma kits, and necessary civilian prescriptions. When a family boards, they immediately get access to survival resources that would otherwise be destroyed. Also, because a family might be enclosed in there for an extended period, maintaining internal pod air quality is a massive engineering requirement. We integrated advanced passive and active cross-ventilation systems to constantly regulate airflow. This prevents carbon dioxide buildup, ensuring total safety and comfort, while they use the emergency blankets, flashlights, and power banks.
Now, one of the greatest paradoxes of a flood is that victims are entirely surrounded by water, yet they have absolutely nothing safe to drink. Contaminated floodwater is a massive public health risk. We solve this by incorporating a mini water filtration system. And this isn't just a simple mesh screen, okay? It utilizes an integrated multi-stage filtration process, featuring reverse osmosis and UVC light purification. It's engineered to process and output up to 15 liters of safe, clean drinking water per hour. We are empowering victims to safely purify the very floodwater surrounding them.
Section 4. Smart Rescue Technology, Guiding the Helpers. Survival is paramount, but the ultimate goal is rapid, successful retrieval.
During a severe flood, the urban electrical grid is almost always the very first infrastructure to fail. To counter this, the Aquashield relies on some really robust hardware. Specifically, 200-watt monocrystalline solar arrays paired with a 500-watt-hour lithium iron phosphate battery. This exact electrical power output specification ensures the onboard emergency lighting, device charging systems, and vital communication stations run continuously. By harnessing renewable solar energy, the pod becomes entirely self-sufficient. This integration massively benefits long-term flood emergency operations because the logistics of maintenance are simplified. The pods don't require daily refueling. Plus, it directly contributes to our city's long-term environmental sustainability goals. Let's talk about visibility. Every single Aquashield is equipped with a 406 MHz GPS emergency beacon that integrates directly with municipal dispatch grids. Combine that with high-output emergency signal LED lights emitting over 2,000 lumens, and you can pierce through severe weather and pitch darkness. Picture a family stranded in the dead of night. These signal lights drastically improve visibility for rescue teams. Beyond just the hardware, we've also meticulously outlined the standard operating procedures for victim rescue and pod retrieval. This details the specific training requirements for municipal rescue teams managing these units, covering things like hook and tow mechanisms and safe civilian transfer protocols and active currents.
Section 5. Broad community benefits beyond the rescue. Let's zoom out a bit and look at the wider impact. The deployment of these pods creates a really powerful ripple effect across the city. Beyond just immediate victim safety and faster rescue operations, this project deeply supports community resilience and public health goals. By integrating this infrastructure into neighborhoods, we can create a clear strategy for involving residents in annual emergency simulation drills. Engaging local neighborhood leaders in the deployment process dramatically boosts overall disaster preparedness. Furthermore, having these highly advanced units visible provides great educational opportunities to increase public awareness about flood safety tech while directly promoting and inspiring applied STEM learning in our local schools.
For you municipal planners out there, this deployment strategy seamlessly links up with global sustainable city development goals, specifically SDGs 3, 9, 11, and 13. To make this actionable, we've defined the operational steps required for authorities to approve deployment. We've set clear criteria for successful pilot program evaluation by city officials, things like achieving deployment times under 30 minutes and maintaining a 100% structural integrity rate during controlled high-velocity current testing. We are fully ready to work through the logistical frameworks to make this standard city infrastructure. Section 6. The future of disaster response, next-gen upgrades. While the current prototype is incredibly robust, we are already engineering the roadmap for tomorrow. Our vision for the Aquashield is dynamic. Future iterations will include larger capacities and live weather monitoring. But the most significant technical advantage is going to be the integration of smart AI alert systems for future units. This AI will allow for predictive deployment based on upstream water level data, autonomously signaling to municipal grids well before the flood actually crests. Combined with emergency medical support sensors, the AI will also manage automated triage, instantly transmitting the vital signs of victims directly to nearby hospitals while the pod is still in the water. It is going to revolutionize how we handle mass casualty potentials. To bring all of this to life, we're proposing a Phase 1 deployment plan, targeting 3 high-risk urban districts. We've mapped out the ideal staging areas for pod deployment in these neighborhoods, alongside rapid transport methods for distributing the units before the floodwaters even rise. Thanks to a design that's optimized for rapid mass production using injection molding, we have charted a realistic timeline for pilot testing within just 6 months, with a baseline cost estimate of only $1,500 per unit. Which leaves us with this vital question as you consider our proposal for MIIEX 2026. How will community-centered design and smart technology shape our resilience to future climate disasters? Thank you so much for your time, and I really look forward to moving into the pilot phase with your teams very soon.